video real quick. So anyway, so waves. This here is just a nice little mind map if that's how your brain works. We're gonna be going over things like this next week, so don't like panic if you don't understand what any of these are. We're just gonna right now we're just gonna kind of go through the basics. So it says a wave is any disturbance that transmits energy through matter or space. And any substance with which a wave can travel is a medium. So if a wave is traveling through something, then it's a medium. Now remember, all of them do not require mediums, like electromagnetic waves don't need mediums, but if it does require a medium is pretty much going to be like a state of matter. So state of matter. And we already know our states of matter from our last test is going to be like a solid, liquid, or a gas. So these are all the different things that a wave can travel through. Now remember, they can be described by how they travel, and they can also be described by what they travel through. So something can be like a transverse electromagnetic wave or like a longitudinal electromagnetic wave, because this is just going to describe how it's traveling, which is more like their shape, really. So if you remember, a transverse wave looks like this. And then a longitudinal wave, they look more like our slinkies. Oh wow, I'm like not an artist, so don't come for me. But yeah, they look more like this. And what they travel through would be like a mechanical needs a medium. And an electromagnetic wave does not need a medium. Not need a medium. Alright, so those are kind of the two differences that you'll see. Alright, so there are the three main types of mechanical waves. Remember, I said earlier that we can have something that's both here and here and here, or we can have something that's here and there, or vice versa. So we're going to look more into how they travel. So a mechanical wave is created when a source of energy causes a vibration to travel through a medium. So pretty much what that looks like is you'll have like something here and here and here, and the particles just kind of like bump into each other. And as they're bumping into each other over and over and over again, it causes a wave. That was a really ugly picture, but like hopefully you kind of understand what I'm trying to say. Alright, and the three main types of mechanical waves are going to be your transverse waves, your longitudinal, and your surface. We don't do too much with your surface waves. Your surface waves are what we've covered a lot in like 6th grade, so this is more like earth science type stuff. But we do like brush over it really quickly. Our main two are going to be these two. These are the main two that we're going to be discussing this year. Alright, so the transverse wave is a wave that vibrate up and down or perpendicular to the direction that they travel. So by perpendicular, I mean if we have a wave that's doing this, and remember we have a resting point. Ugh, my art skills are being tested today. We have a resting point. Let's pretend this resting point is straight. I can't draw. So we have a resting point here. The particles, you know how I said they bump into each other? They are going to bump into each other kind of an up and down motion. That's what gives us this wave here. And by perpendicular to the direction they travel, I mean like they do this. Like it's like a nice little, I can't draw. But it's more up and down than it is side to side. Perpendicular just means like something is more up and down than side to side. Longitudinal is going to be parallel. So the longitudinal waves, see, these move more side to side. Yeah, so that's how those are moving. And a surface wave, like this, like the wave we're most accustomed to, is a wave that travels both vertical and forward. So you notice like when you're standing and you're like at the beach, you're like, oh, lovely beach day. And you see a wave coming, the wave is not just gonna like stop in the middle of the ocean like some of them do, but like if you're standing there and you see a wave coming for you, it's not just gonna be like, oh, just kidding, we're just gonna go straight up and down. Like, no, they're coming forward and they're still like, they still have a little bit of height on it. So because it has both, that's what makes it a surface wave. So back to our transverse. Wow, like this one looks way better than any of my drawings ever could. So the transverse wave, the direction of travel is going to be going in one direction, and the particles, like I said, move up and down. In a longitudinal wave, they're still going one direction, but our particles, as you can see, are moving side to side. So think of like a slinky. I have a slinky, but it is at the school. So yeah, so you're thinking of your the particles moving more side to side or parallel. Again, transverse wave, see they're moving up and down, just like I said, and then perpendicular. So they're going da da da. Perpendicular is like a right, it's like a right triangle. Longitudinal, again, da 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 da. See? Perfect. Alright, so waves are described by what they can travel through as well. Electromagnetic waves, overall, they just do not need a medium. So they do not need a medium at all. And a mechanical wave needs a medium. So think mechanical, medium, electromagnetic, I don't know, just doesn't need it. So mechanical needs a medium. So medium, mechanical. Alright? Electromagnetic waves are typically going to be your light waves, because light waves can travel without a medium. They can just keep traveling and traveling and living their best life. But a sound wave is a mechanical wave that you need. So you need to have like something that goes with it. So one of the more famous examples, like if you watch like shows like Star Trek or any of those cool shows, they're like out in space and they're talking. I'm sorry to burst your bubble, but like that's not scientifically accurate. They can't actually talk in space because space is a vacuum. So unless they're like in like, I don't know, like let's say they're like in their spaceship and their spaceship has oxygen in it, then that, because it has air, now they can talk. But like there's no way they're just like floating out in space and they're just like talking to each other. Like you can't talk in space. So anyway, yeah. So like I said, a medium is going to be your solid, your liquid, or a gas. So a medium is just going to be just going to be a state of matter. My handwriting. Yeah, it's going to be a state of matter. And these are the characteristics of a wave. So please make sure that we know these. These are what typically comes up on like tests and quizzes. I know for a fact I'll be on a test, but I might be on your quiz on Friday as well. Trough and a crest. Okay, so the crest, let me get a different color. Okay, of course I would get the one color that's like already there, but whatever. Pink, why not? All right. So a crest is going to be your highest point on a wave. So a crest in this case would be like here, or it could be like here, or it could be like here. This is going to be your crest, just the highest point of a wave. So wherever you see the point is the highest is your crest. Your lowest point is going to be your trough. So any of those could be considered a trough down here. The amplitude is going to be the distance pretty much. So amplitude is the height of your wave. So how far is your wave from the resting point? We don't really calculate this, but you just need to know where it is. So it's going to be the height of a wave. And your wavelength is just going to be like from, just like, you're just going to count them really. Let me get rid of some of this. So it's going to be either from crest to crest or from trough to trough. So let's say I want to calculate my wavelength for this. So I'm going to say, okay, so from crest to crest, and then I would measure here, or from here to here, and I would measure here, and that would give me my wavelength. Now we don't measure wavelengths. Also, we just need you to know how to find them. And the frequency is the number of waves produced at a given amount of time. So let's say this is my wave, right? And I want to count the frequency of this wave. I'm going to first look at how many wavelengths that I have. So how many waves do I have? And then I'm just going to decide from there. So I have one wave here. Here's one. I'm going to have one here. There's another one, so that makes that 2. That looks like it's about to be a wave. I'll count it. 3. So my frequency here would be 3. It'd be 3 wavelengths. So that's all you have to do. You just have to calculate. Or I can calculate from here to here. It's like 1 to here. Now to give me 2. So let's not count this one. It's not even a full wave. So I felt really bad about counting that one. So my conscience wouldn't let me count something that was wrong. Anyway, there we go. Alright, so you have 2 wavelengths there, or you can count from the bottom 2 wavelengths. I prefer to count crest to crest. I don't know. It's just my thing. But, you know, live your life. Alright. The resting position is just this line that's down here. So remember that I couldn't draw a straight line earlier, and I probably still can't draw a straight line. Wait, it's almost happening. Oh, we tried. Okay, well, I failed. Anyway. So your resting point is just the middle part of your wave that divides the crest and the trough. So it just divides the top from the bottom. And again, your amplitude is your height of the wave. So think amplitude, think height. So you know, like, I don't know if you guys are like hardcore like guitar players or anything like that, and they'd be like, up the amps. Ding. Amps. That's gonna make it louder, right? If you up the amps on like, wow, I'm really out of my wheelhouse now. If you up the ampage on like your speakers, then it gets louder. So fun fact. So here are your amps. And if you make it louder, because you're increasing your height of your wave, then there's your amplitude. Alright, that was a reach, but we got there. Okay. So the wavelength, like I said earlier, is from crest to crest or from trough to trough. And here is our perfect wave here. So again, let's just practice. So I would have 1 frequency here, 1 wavelength here. So this would be a total of 2 wavelengths. This is a mechanical wave. It's a transverse. I kind of guessed on mechanical. You can't really tell unless it's medium or not. But so you have 2 wavelengths. We have a transverse wave. Forgive me, my brain is not fully functioning. And yeah, we can measure the amplitude from here to here. A lot of times we will just give you like something that looks like this, and we'll just be like, label it. So you just label them based off what this is up here. Alright, so let's get into the wave characteristics. So wavelength and frequency are actually related. So as wavelength increases, your frequency decreases. So that's just, to me, it kind of just looks more common sense, but you can always just kind of like measure it too if you want. So if I have, I don't know what they're trying to say here. Okay. So the number of complete waves we have is 1, 2, and 3. So here's 2 and here's 3. And if we notice that the longer the wavelength, so let's say I have 3 here, and that's a pretty long wavelength, right? Now the shorter wavelengths, I'm able to get more within the same period of time because they're shorter. So I have 1, 2, 3, 4, 5, 6, 7. So notice that the more wavelengths that I have, right here, where is it? The more, yeah. So up the wavelengths, down the frequency. Up wave, down frequency. Or I can go more frequent, like this one down here. They happen more frequently. Okay, that was my joke of the day. And lower the wavelength. So the more often that a wave occurs, the more frequent that it is, but we're gonna have a shorter wavelength because, you know, it just takes up more space. You can't get quite as many waves in the same amount of space if we don't just shorten them up a little bit. So again, down here, as wave frequency increases, so as, you know, we have more is we have more of these little lumps here. So as wave frequency increases, then the wave energy also increases. So keep that in mind as well. So the more of these little like this one's gonna have way more energy than this one. So if you see a wave that's like dun, 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 it's really slow. It's a really slow wave. These are gonna be like your radio waves, like they're really slow. But you know how people will be like, oh no, 5G is so bad. It's because those are like, they look like this. they're really tight waves, right? They're not gonna look like your radio waves. That's why, you know, sometimes it'll be on the radio. And it's really easy for interference to come in and kind of mess this up because they're kind of far away from each other. But when you have like those quick little waves that go do 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 like that, there's not as much time for things to like kind of interfere in there. So it's like they're really fast little radio waves. So anyway, this is gonna have more energy than this slow gigantic wave down here. So frequency, the more frequent, the more energy. I look like I just wrote a bunch of squiggles, but I really hope you kind of understand that, because that is also very important. So please put this somewhere in your notes. This is like really important. They do like to ask questions like this, especially on like tests and quizzes. They like to ask you about relationships of different things. So energy and frequency, they are in frequency increases, wave energy increases. So frequency increases, energy increases. Doot, doot. Right. Any motion that repeats at irregular time intervals is a periodic motion. So the time required for a wave to fully complete one cycle is a period. So within a period, that's just like from this resting point to this resting point, we would call that a period. So however much time it takes for us to go from one point to the next, that's just your period. It's like a period in time, you know, like on a timeline in social studies, just like that. And again, frequency is the frequency of a wave is the number of complete cycles in a given time. So if we have a given period that I have like right here in this little yellow box that I have, then I count my frequency. So I have 1, 2, 3, 4. So I have a frequency of 4. Here, frequency of 2, and just 1. And a frequency of 1. Alright, so that means that this one right here is going to be a lot more, gonna have a lot more energy, right? Yup. So, where's my life? There we go. So, inversely proportional. So, to increase the frequency of a wave, increasing the frequency of a wave decreases its wavelength. So, you know I talked earlier about the energy and the frequency both increasing. So if we increase the frequency, so again, we increase how fast something's moving, then the wavelength is going to decrease. So we talked about that a little bit earlier, that this is going to move a lot faster than this one. All right, and we calculate this with wave speed equals wavelength times frequency. So the greater the amplitude of a wave, the greater the energy as well. So if I have more amplitude, then I'm also going to have more energy. You know how I said, raise the amps? I don't think anyone says that anymore, but I'm saying it, okay? So if someone says, raise the amps, right? Something with a low amplitude, this one is not going to be nearly as loud as this one. I feel like there was like a point when like we could like look and see like the amps and stuff on songs. Like I know there's like I don't know what it's called anymore, but I know there was like a wave that people used to just like casually listen to music and like you could see the amps. Maybe I'm just old. Maybe people don't do that anymore. I'm just kidding. Okay, whatever. But yeah, the amps are here. So a high amplitude, this is going to be louder than this one. So what are the 3 types of mechanical waves? That will be right here. So we have longitudinal, transverse, and surface. All of those are mechanical waves. Describe 2 main types of wave classification. Well, we have mechanical and electromagnetic. Remember, mechanical, medium. Electromagnetic, no medium. Right? Perfect. And which type of waves need a medium? Well, that's mechanical. Remember, mechanical mediums. Because we make jokes in this class. Okay. Which of the following is a medium or a media? That's going to be solid, liquid, and gas. Waves do not need a television, cell phone, or radio to travel. They need them to travel too, but they don't need them, to travel. So solid, liquid, and gases are our mediums. And then down here it says to draw a transverse and a longitudinal wave, and we're going to label all the parts. So here is my transverse wave. Okay. And there's a spot that goes in the middle. Alright. So in a transverse wave, we're going to draw this one first. So we have a crest up here. Way down here, we're going to have our trough. And then our amplitude would just be the height of our wave. So here's my amplitude. And my resting position is going to just be this little spot right here. Right? Alright, perfect. Now, let's look at a longitudinal wave. So a longitudinal, I'm really bad at drawing these, so... And then they separate, and then they come closer, and then they separate, and then they come closer. Alright, so in this one, we have... Well, we don't really do that here. We do compressions and rarefactions. So, here and here. These two are going to be compressions. Or it would also be like the crest if we were looking at like a transverse. And then these down here are rarefactions. No joke, it took me like 2 years of teaching 8th grade science to like realize that it was rarefactions and not a rare fraction. I don't know, I always wanted to make it a rare fraction, but it's a rarefaction. And then our amplitudes can be found by how quickly or how closely these are together. Here. In our resting position, this one we can't really tell. It's a longitudinal wave. So that is that. Yeah. Alright, so that is all that I have for you guys today. Like I said, you guys can ask me any questions via talking points and I'll do my best to answer them. But this should be everything that you guys need for your quiz on Friday. So you can always like pause, review, whatever you need to do with this video. I know it helps when like lessons or lectures are kind of recorded, so you can slow down, because I know that I do talk very quickly, and I'm trying to do better about that, but life. So hopefully this is helpful, and I will hopefully be seeing you guys soon again, so that I'm not like sick anymore. But anyway, thank you guys for your help, and that's it.